Hello everybody, welcome to this video series provided to you by KET Academy. So this is the first part of this video series, meaning that there are other parts of the videos that will be coming up. So this video is meant for ordinary level students. So if you're in Form 5, Form 4 or Form 3 and you're offering mathematics or additional mathematics, therefore this video is meant for you. So we are simply going to go directly to solving these questions. Now, the first part says that simplify 1 on 27 raised to the power negative 1 on 3. So, I've been given that, want to simplify that. So, the first thing we need to do, we have to recall all our formulas. We have been asked to simplify 1 divided by 27, all of that minus 1 on 3. We know that from indices and logarithm, when you have a function, let's say a raised to the power negative 1, this can be written as 1 all over a. So we need to have that in mind, meaning that we can write this as 1. Now all of that should be divided by 1 all over 27, all that raised to the power 1 on 3. Now we've applied this and we've gotten that. Now what if we try to apply this? Another law states that if you have a all over b, all that raised to the power c, then this can be written as a raised to the power c all over b raised to the power c. Now with this in mind, we're simply going to apply that here, meaning that we can have 1 divided by 1 raised to the power 1 on 3. So it should be like this: 1 raised to the power 1 all over 3. Now divided by 27, all that raised to the power 1 all over 3. So this is equivalent to 1 divided by 1 divided by. Now this is the same as the cube root of 27, which is simply 3, meaning that 1 divided by 1 divided by 3 is equivalent to 3. Therefore, when you simplify this, you're going to have 3. So that's the solution for the first question. And if you notice, or if you look at this critically, you simply see that we are applying the laws of indices. So it suffices that you should know all the laws by heart, meaning that when you're faced with a challenge, you should know the exact law of indices to apply. So we're going to continue to the next part. It says that look for the value of x, given that 3 raised to the power x plus 2 is equal to 27 raised to the power x. Now, under indices, when two indices of the same base, when you equate two indices of the same base, therefore the power should also be equated. So what we are going to struggle to do here is to make the bases to be the same. We know that this is already written as 3 raised to the power x plus 2. So we know 27 can be written as 3 times 3, all that raised to the power x. So this is the same as 3 raised to the power x plus 2. And also from the law of indices, which states that a raised to the power b times c raised to the power b, this can be times a raised to the power c instead. Now we notice that they're having the same base, right? So we are going to maintain the base and we simply add the powers b plus c. Okay, meaning that this can be written as 3 raised to the power, since it's raised to the power 1 here and raised to the power 1 here, we'll simply write this as 1 plus 1, which is definitely 2. Now all of that raised to the power x. So this can be written as 3 raised to the power x plus 2 to be equal to 3 raised to the power 2x. Now since the bases are the same here, since the bases are the same, we are going to equate the powers, meaning that we can write that as x plus 2 equal to 2x. So meaning that 2 should be equal to x. So basically the value of x is 2. Now you can always verify your answer, meaning that if you put 2 there, you're going to see that if x is 2, if I'm not mistaken, then you're going to see that 3 raised to the power 2 plus 2 will simply be equal to 27 raised to the power 2. Now this is the same as 3 raised to the power 4, right? That is the same as 3 raised to the power 4. Now 27 is the same as 3 times 3. Now all that raised to the power 2. So this will be 3 raised to the power 2 equals to, here is 3 raised to the power 2, all that raised to the power 2, which is 3 raised to the power 4 equals to 3 raised to the power 4, which are equal. Now when you have these, they are equal, right? Meaning that it's our answer here is correct. Meaning that this answer is correct. So you could do, it's not possible to do for the first part. Now going to the last part, we have been given logarithm and we've been asked to simplify this log. So there are also lots of logarithm. I think we are going to solve more examples under logarithm, not just one. So here it states that we have been given log 0.25. To simplify this, we have to note that here we haven't actually been given a fraction, because most of the times the laws of logarithm express all the values in fractions. Here we haven't been given a logarithm in terms of a fraction, because most of the times the laws of logarithm are always expressed in fraction forms. So the first thing we need to do is we have to convert this to a fraction. We know that alternatively we know that 0.25 can be converted to fraction by simply dividing by 100, meaning that this can be written as 25 divided by 100, which is the same as 1 on 4. Now instead of writing this, we're simply going to have the log of 1 on 4. We already know this, right? So we can simply write this as log 1 minus log 4. Now all of these are in base 10. Log 1 is definitely 0, so this can be written as minus log of 4 base 10. So you can end at this level.